Good morning to all. Next we will discuss Bernoulli's theorem. What is Bernoulli's theorem? First I will explain Bernoulli's theorem. Actually this is the pressure energy. So pressure energy, kinetic energy, potential energy. Summing sum of all the energies, all the three energy of unit mass is equal to constant. Only thing is, three conditions we must satisfy. That a liquid which is flowing is incompressible. That liquid is non-viscous. The same manner, the liquid is streamlined. The liquid satisfy these three conditions. That means liquid is incompressible, non-viscous, streamlined. Then pressure, the sum of pressure energy, kinetic energy, potential energy per unit mass is equal to constant. This is the theorem, Bernoulli's theorem. What is Bernoulli's theorem? We consider a liquid of incompressible, non-viscous, streamlined. The sum of pressure energy, kinetic energy, potential energy per unit mass is equal to constant. Actually, this is the theorem. This can be written by mathematically as P by rho. P is the pressure, rho is the density, V is the velocity, G acceleration due to gravity, H is the height of the liquid column. This is the pressure energy per unit mass, kinetic energy per unit mass, potential energy per unit mass is equal to constant. That means how this be derived? Just you see the potential pressure energy. Pressure energy formula is P by rho, that is pressure by density into mass. Then pressure energy per unit mass. Then pressure by density. The mass getting cancelled. Then pressure by density is the pressure energy per unit mass. In the same manner, kinetic energy, you know the formula of mv square. Here the kinetic energy per unit mass can be written as potential energy, that is mgh, potential energy per unit mass, that is potential energy divided by mass. M getting cancelled, that is mgh by mass, that is mm getting cancelled, remaining gh only, that is potential energy per unit mass, that is gh. Here pressure energy, kinetic energy, potential energy per unit mass is the sum of pressure energy, kinetic energy, potential energy per unit mass is equal to constant. But only thing is, the condition is the liquid should be incompressible, non-viscous, streamlined. This is the Bernoulli's theorem. This can be proved with the help of small calculations. This can be proved here. Let us consider this particular diagram. This is a water flow. This is a tube in which the water is flowing. This is a point A. This is point B. The area of cross section is A, capital A. That is area of cross section at A. Here, area of cross section at B, that is small a, capital B. Velocity in this terminal, the molecules, the water molecules flowing through the terminal, the velocity of the water molecule is BA. Velocity of the water molecule at B is BB. The same manner, pressure at B is BP. Pressure at A, that is PA. So pressure at A. From the ground, the height of the A terminal is H1. The height of the B terminal is H2. This is an arrangement. We are going to prove Bernoulli's theorem. Let us consider the first point. That is the force at A. The molecules are here, water molecules, liquid molecules are there. That is the pressure, that is the force on the water molecules. That is the force at A. Force at A can be written as FA is equal to PA into AA. You know the formula, that is pressure is equal to force by area. You know the formula, pressure is equal to force by area. Cross bracket. That is the force is nothing but a pressure into area. That is the force is nothing but a pressure into area. The force at A, that is the pressure at A, then area of cross section at A. That next, that's a distance. D is the distance through which the water molecules are traveling. The water molecules travel in t time, t seconds. Then distance is equal to velocity into time. Here also there is a basic formula. There is a velocity is equal to displacement by time. Displacement by time. Displacement d, time t. Then displacement is equal to velocity into time. Velocity into time. That's a displacement is equal to velocity into time. That is a velocity at A, then time. Product of these two, displacement. Then next one is, what is the work done? Move the particles through this terminal A. Work done, the basic formula, force into displacement. Work done is nothing but a force into displacement. Already you know the force. Just to substitute this value, PA, AA. Distance, you know the formula, there is VAT, that is VAT. This again simplified with the help of this particular section, that is VAT is equal to displacement, you know. This displacement and the area of cross section is nothing but a volume. This is what? Volume. This is what? Volume. That is area of cross section and displacement gives, that is nothing but a LBH is the volume. That is BH is the area of cross section. L is the length or distance. Length or distance. Then length and area of cross section gives you volume. That means here area of cross section and distance gives you volume. Here just to change area of cross section, here these two are distance, area of cross section and distance gives volume. That is PAB is the work done to move water molecules across terminal A. Across the terminal A. This is the thing here. Then one more thing is work done. We found work done This work done is nothing but pressure energy. Work done is nothing but a pressure energy. Work done is nothing but a pressure energy. Then this can be changed as that's a pressure energy. Pressure energy is equal to PA into V. That is PA. That is a pressure at A and volume is the volume. Pressure at A into volume gives the pressure energy. This is the thing here we found pressure energy. Next, this pressure energy can be written in somewhat different angles. Listen here. This is the pressure energy. We found the pressure energy. Pressure energy per volume. That is pressure energy PA B per volume V getting cancelled. That is pressure at A. Pressure energy per volume is equal to pressure energy at A. Pressure at A. Here the pressure energy per unit mass we are going to find. Pressure energy per unit mass. That is a pressure energy per mass. That is a pressure energy, PAB by mass M. Then you bring this mass denominator, then PA mass per volume. Mass per volume, density, mass per volume is a density. Then instead of mass per volume, just to write a density, that is PA, that is a pressure at A divided by density of the liquid. Pressure at A divided by density of the liquid. Next, we find the pressure energy of mass M. This is the unit mass. This is the pressure energy of mass capital M, just made a product of this previous value. That is the pressure energy PA by rho into mass. That the mass of the substance is M, that is into M. Let us consider this equation number 1. Next, let's have potential energy at A. Potential energy at A. The potential energy at A is nothing but mgh. That is HA. This is the second equation. Then kinetic energy at A. Kinetic energy at A of mVA square is the kinetic energy at A. We found pressure energy, potential energy, then kinetic energy at A. Now you find the total energy. Total energy, that is a total energy is nothing but a pressure energy, kinetic, potential energy and kinetic energy. Just substitute all those values. That is a PA by rho into M, mgh plus of mVA square. Just substituting all the equations here to get a total energy at A. Then the total energy at B, similarly, instead of A, just to write B, that's all. Instead of A, just to write down B. Then the pressure, total pressure energy at B, that is B by rho into mass, that is mgh that is M of mVB square. This is the total energy at B. This value is the total energy at A. This is the total energy at B. According to conservation law of energy, you know already conservation of energy, the total energy is constant at any point. Total energy is constant at any point. That is energy at A is equal to energy at B. Already you found that is energy at A, that's the total energy at A, total energy at B. These two are equated since we are applying law of conservation of energy. That means total energy at any instant, at any point is equal. Here divided by throughout M, throughout the equation by M. That's a dividing. Here the m getting cancelled, here also getting cancelled, here also getting cancelled. Then the equations becomes PA by rho, that is GH of VA square. The same manner this side, just divided by m, then the m is removed. That means this 3 energy is equal to this 3 sum of 3 energies. That means generally we can write P by rho is equal to GH is equal to of mv square, which is constant. This is the law, that is the Bernoulli's theorem. We proved. That means pressure energy per unit mass, potential energy per unit mass, kinetic energy per unit mass, adding all those things is equal to constant. That means the sum of pressure energy, potential energy, kinetic energy per unit mass is equal to constant. Only thing is that liquid should be incompressible, non-viscous, streamlined. Actually, this is the Bernoulli's theorem that we proved clearly. It's a very important question.